Welcome to Math Challenge 561. Math Challenge for all quantitative and numerical aptitude tests. Now here we have a rectangle. The width of the rectangle is 36. The height is not given. And we have three semicircles. Right? We have a rectangle with three semicircles of different radii, different diameters. And we have to find the area of this rectangle. The width of the rectangle is given. The height is not given. We have to find the area of this red rectangle. Math challenge 561. And look at the animated dotted line. In the largest semicircle, look at the animated dotted line, the red one. The red dotted line, the animation. This is the radius of the largest semicircle. This is the radius of this semicircle. So supposing this radius is r units. So if the radius is r units, this diameter would be 2r units. You can see the animation. This is the radius of the largest semicircle. So if this is r units, then the diameter would be 2r units. So we get the radius as r and the diameter as 2r. Now look at the animated blue dotted line. You can see the blue dotted line animation. This is the radius of the semicircle in the middle, the smaller semicircle. And if the full is r units, then this would be r minus 5. The full radius of the first semicircle was r units. So this animated blue line, the radius of the second semicircle would be r minus 5 units. So its radius is r minus 5 units and the diameter would be twice r minus 5 units. Look at the blue animated dotted line. The radius, full radius of the largest semicircle is r. So the full is r. The top part is 5. So the radius would be r minus 5. So if the radius is r minus 5, then the diameter would be twice r minus 5. Now look at the animated dotted line of the last smallest semicircle, black dotted line. You can see the animation of the dotted line, black dotted line of the smallest semicircle. So the full was r, the top part is 7, so the radius would be r minus 7. The radius of the smallest semicircle, look at the black animated dotted line. So this radius would be r minus 7 and diameter would be twice r minus 7. You can see the black dotted animated line of the smallest semicircle. The full is r and this is 7, the top part. So the radius would be r minus 7. So its diameter would be twice r minus 7 units. So we got the radii as r minus 5 and r minus 7 units. So we got the radii of the first circle r, the first semicircle r, the second semicircle r minus 5 and the third semicircle r minus 7. So the diameters would be for the first circle 2r, for the second twice r minus 5 and for the third twice r minus 7 and the total is 36 given. So 2r, that is diameter of the largest semicircle, twice r minus 5, that is 2r minus 10, that is the diameter of the second circle, and twice r minus 7, that is the diameter of the smallest semicircle, 2r minus 14, that is equal to 36, giving you r equal to 10. 2r, that is the diameter for the first circle, 2r minus 10, that is the diameter for the second circle, and 2r minus 14 diameter for the third circle, that is equal to 36, giving you r equal to 10. So the width is 36 and radius, which is the height of the rectangle. You can see the first largest semicircle, the radius is the height of the rectangle. So the width is 36 and height is 10. The height is equal to the radius of the largest semicircle. So radius equal to 10. So area would be 36 into 10, 360 square units. right? R we got 10. R we got 10, which is the height of the rectangle. You can see the largest semicircle. So R equal to 10, the height of the rectangle 10, the width is 36, so the area would be 36 into 10, 360 square units. So the required area would be 360 square units. And that was Math Challenge. We bring you interesting questions and problems for school level math, Olympiad junior and senior levels, university admission tests, and quantitative numerical aptitude tests at all competitive examinations. Remember, all our services are entirely free of charge, and we have free online class once a week for students from all over the world. So any student from anywhere in the world can contact with their problems, all the service being entirely free of charge. We shall come back again with more interesting problems, more interesting questions, more interesting challenges. Till then, thank you and goodbye.